Alright, this is example 1, section 4.2, parts C and D. So we're solving quadratic equations by factoring to determine the roots of these equations. So we'll use our sum product method here. And I like to do these by writing out what my sum and product are like this. And it almost makes a little puzzle out of factoring. And so if our product is 12, we can write out the factors of 12. And this is handy when you're first getting back into factoring. After doing enough of these, you'll have this really quick. But as you can see, if we're adding these two factors together, there's only one way we can get to 7, and that's by using 3 and 4. So those are our factors. So we'll write out that x plus 3 times x plus 4 equals 0. And you could FOIL this out to check it. Then we want to treat each factor separately, set them equal to 0. And we will solve these little equations for x and get that our roots are x equals minus 3 and x equals minus 4. Alright, pretty straightforward. Part D, there's one extra step here at the beginning. Of course, we want all of these quadratics to be equal to 0, and this one's equal to 72. So we will, we're going to move the 72 over to the left-hand side of the equation by subtracting 72 from both sides. And that gives us x squared minus x minus 72 is equal to 0. Now, we can do the same thing. Here our sum is negative 1. And our product is equal to negative 72. And we could write out all the factors of 72. But I know that if our sum is negative 1, our two factors are going to have to be pretty close together. So what I think of right away is 9 and 8. And if we want negative 1, we want our larger factor to be the negative 1. So we'll go negative 9 and positive 8. And negative 9 times 8 is negative 72, and that one works out there. Okay, so we will write out that x minus 9 times x plus 8 equals 0. Set each factor equals 0 separately, like that. And then solve each equation for x. So we get our factors of x is equal to 9 and negative 8.